Hello, episode 14 of The Circuit. I am Ben Bajarin.
Greetings, Internet. I am Jay Goldberg.
Hope everybody had a good weekend. This week, we're going to talk about a subject that we both did some market work on recently, so it's top of mind, but it fits into the broader category that honestly doesn't get talked about as much. Internet of Things, and specifically the marvelous world of sensors is the little colorful verbiage I like to use. But one thing that hits me is interesting. We haven't seen and I'm blanking on when this was. Maybe it was late teen 2000s or whatever. There was there's gonna be 30 billion connected devices by 2025, right? Those giant forecasts of IoT, and that happened for a couple years, and now we don't hear anything about IoT forecasts anymore or billions of connected devices. Yet we are actually accelerating this move from analog to digital, and things that were not connected are becoming connected, right, at scale. So I think it's interesting, right? But in kind of my grand thesis is there's two IoT markets. There's the penny processor, really, really high volume, but not big ASP types of products, which we'll talk about today because it's actually really interesting and large market. And then there's the higher ASP, so IoT products that might have computer vision, audio video sensors, temperature sensors, scent sensors for, whatever, something that's a combined package that might sit on a light pole or obviously in automotive if we consider IoT and that. So things that have high compute. So there's two markets, right? There's the low volume, kind of higher margin, high cost, so premium IoT. And then there's the big scale part of that market where we're still seeing a lot of sensor work still get fleshed out at a low power range. So that's kind of my lobbed out thesis I'm throwing at you.
Right. So I look at it differently. I don't think of it as two markets for IoT. I look at it as 30, 40, 50 different markets for IoT. And I think part of the reason everyone got excited about it was because of those big numbers. But everyone assumed it would be one thing. It would be one compute platform, and we'd be able to have some economies of scale that would allow really interesting platform dynamics. And that didn't develop. And so part of the sort of overall I think people are just kind of tired of IoT. There's a lot of IoT fatigue.
Right. Yes.
In the industry, just because it was never that, tens of billions of market. It's lots of very fragmented niche segments where every industry and every use case is a little bit different. And so I wrote a post, 4 or 5 years ago called IoT is a Mess, just talking about this. And I think the problem isn't with the idea of connecting all these things. It's the idea of lumping them all into one big market.
Right.
I like your approach of sort of saying some of these things need high compute, some of them need low compute. But I think it's even trickier than that because every IoT module out there is really a combination of three elements. Right? You have some kind of sensor or actuator, like taking in real world data or doing something in the real world. You have some kind of decision making chip, and then you have connectivity. And within each of those categories, there's 20. I have a list of 25 different sensor types. And in terms of logic, I mean, it can be anything from a 4-bit MCU microcontroller to a CPU. And then connectivity. There's another half dozen options there. So you do the combinatorics of that. Every use case is going to be some different combination, and it's like dozens and dozens, hundreds of use cases, which is hard for people like you and I to be analytical about. But it's still, I still think the overall trend is there. I think we're going to connect more and more physical objects. I actually think it's going to be much bigger than people anticipated. I think it's ultimately we're going to measure it in trillions of devices.
Sure.
Right? Yeah. Trillions of objects, I'm going to call it, because at some point, we're getting to the point where you can buy a Bluetooth tag for 25 cents, right? It's basically an adhesive, disposable. At that point, it's disposable. So you can start putting it on, maybe not an individual can of soda, but certainly a 12 pack, right? And you start going down that path. There's lots of gains we can generate, a lot of value in that by tying all that data into software.
Yep.
It's just going to take a while, and it's kind of messy in the process, but it is massive. We just have to think about it differently.
Yeah, no, I totally agree on the trillions number. In fact, there was a conversation around this I was having at a VC trend presentation I was giving with partners, where I had said, that this will actually be trillions, not billions. And it took a while to flesh that out. But when you take that approach of basically saying, and I think this is an interesting question relative to this, what won't be connected, right? It's not a matter of what will be connected, like what won't be connected. And if you recall, right, there was around this time that IoT was being spun out into this large number, we had things like we were having these beacons discussion. You could make these really low power beacons, stick them on anything. They transmit every little bit, either at a retail store or in oil or gas or whatever. And it didn't need to necessarily be persistently connected. It was just basically giving an update of something, right? What the pressure was of that system, and part of that was just because battery, technology was lagging. Then it was hard to have something that was connected, but they were really cheap to make, right? Or I remember seeing a demo of printable RFID tags. Like you could print these things in mass scales of this paper on this printer and take them out and stick them on, and it was just a little, connected, scannable RFID tag. And to the degree that we say that that's connected, the point is there's lots of analog objects in this long arc of time from analog to digital, that everything becomes connected. It's just a matter of what does that system look like? How is it transmitting data? What's the backend infrastructure that you're collecting on that data? All those interesting questions. But there's inevitable value as things become connected to product companies, retail, anybody, right?
Right. It's just it's massive. But it's gonna come in fits and starts as different categories, different industries adopt solutions. It's part of digital transformation at companies. That's a term I don't love, but as companies become more and more digital, there's lots of value out there that we can tap into as the economics on the IoT part of it, the connectivity part of it improves. Right.
Well, and I think the term digital transformation gets used fairly liberally, but the point is that as a company goes through that process, that's when they start saying, well, maybe more of my pressure sensors on my oil rig should have some form of transmit data, so I don't need a human walking around every on the hour with a paper checkboard, and all those different decisions that they're making to connect parts of their infrastructure that was unconnected. I mean, again, right, you have to first go through some form of digital transformation to even make that leap. So it's a necessary first step, which is why I think it's interesting, right? If you believe that COVID rushed forward some form of digital transformation, that's kind of why I think these conversations are coming up again. And a lot of companies in the semiconductor supply chains are seeing these low power sensors, these small microcontrollers start to take shape again, because you're trying to solve some of these problems that are now being asked now that a company has gone through a much more digitization of many of their processes.
Yeah, I totally agree. And I think that's on the sort of customer side. I think there's some big changes on the product side as well that are going to be really important. Years ago, I was involved in a pitch to somebody who makes, I'd say General Electric, right? Who makes big power, big turbines, right? The windmills, right? And I think he was the CTO of that unit or something like that. And we were trying to make an IoT pitch to him, and he said, "Oh, we're going to help you collect all your data." He's like, "Guys, we already collect all our data. 99.9% of it is useless."
Right.
It's at 0.1%, and those are my economics. But what's happened now is the cost of producing some of these systems and the precision you can get for a much lower cost have improved dramatically to the point where it's starting, that equation is starting to work out. For you don't have to spend tens of millions of dollars to build out an IoT system anymore.
Right.
It's suddenly worth it to collect that 0.1% of data. It's valuable.
Right. Well, and another thing I had mentioned a couple episodes back, I think is interesting, is the glut of, call it, semiconductor inventory that came out of the supply constraints we had in that industry actually brought lower costs from a lot of manufacturers who were all of a sudden like, hey, I've got all this volume. Now I need to figure out what to do with it and go in and start to find these applications. So it became more cost effective, right, to go and do these things.
Right. And I think that's gonna accelerate. I was actually doing a project recently looking at analog capacity, and there's a lot of capacity coming online soon. There is. It's uneven, but there's a lot of analog capacity that was people started making big plans 2 years ago. They're still committed to those improvements, and there's going to be a lot of analog capacity out there, and it's going to be really old, mature processes, 200 millimeter wafer stuff, like old product, old process. That's going to be really good for very, very cheap things.
Yeah,
I
agree.
Think that's going to feed into this.
And I think part of that too is just coming out of a lot of companies now starting to see this as, or a lot of foundries starting to see this opportunity as a way to keep monetizing their legacy edge stuff. That's the products that were on those really small late processes, really late stage, are now moving up to 28 nanometer or 22, right? Something a little bit more dense. So you have all this extra capacity coming on, and you've got a lot of those in China, right? Same way, a lot of trailing edge in China looking for those applications. So if you're a Honeywell, right, who does a lot of these kind of low sensor things, or others who are like, hey, we can now really start to attack this market we identified 5 years ago, and the economics are good for it. Oh, and by the way, they've got a way to analyze that data. Then that becomes an interesting path to. But it's just like my point is, like, this is all really interesting. You see these things happen at the supply chain and component level, but they don't really get talked about because it's not as sexy as like smart home, for example, or something that a consumer can appreciate. But you Chevron, you whoever who's doing more of this on your rigs, or you construction company, it's really valuable, right, to your operating business.
Right. So we've been working on this thesis around sensors, where we think there's sort of three big things that have changed in the last few years. One is the cost and capabilities of sensors have improved pretty radically. And that's largely just tied to the improvements that we see in semiconductor manufacturing overall, and cost curves coming down for some trailing edge things. So you can suddenly, we're capable of manufacturing things, of fitting things into the semiconductor manufacturing stream, add a tool, and suddenly you can make these incredible sensors for very, very cheap. You have the economies of scale of the foundry ecosystem, plus sort of some advanced capabilities. You suddenly have really, really high performance, high spec filter sensors that are capable of doing things and are affordable. Like, they're not $100 sensors; they're a few dollars, 30 cents. You can much more capable than just a generation ago. So I think that's been a big change. The other thing that's changed is on the software side. Suddenly we can start to use that data in much more meaningful ways, right? And this, we just call this AI, but sort of advances in software overall have made that data more useful. And so I imagine that someone like GE probably gets more than 0.1% of value out of their data. They're able to manipulate that data and mine it a lot better. And so that makes it so you have supply and demand both improving, product and usage both improving pretty remarkably just in the last few years. And then on top of all that, I think the big change has been the new sensor companies that are coming up, of which there are a lot, have learned the lessons of the industry and seen, like, it's not just about selling a single sensor. What we really want to do is sell a service or sell a solution. And because some of these sensors are so capable, they're able to do a broader sale. They're able to, capture more of the value of the sale, which I think is going to be really, really important for, because I think when you and I were coming up, sensors were an afterthought. They were sort of, they were commodity. Nobody really thought about them. We'll just get the cheapest ones we can from Korea or Taiwan. And now we're talking about some really, really cutting edge sensors that are performant and powerful in their own right, but because the companies that make them have wider revenue streams, they're able to maintain funding and keep the R&D going so that they don't end up as a commodity. Right. So I'm working with one company, and I don't want to name them, but they make these incredibly high precision position and voltage sensors. They use magnets, right? Really, really advanced magnets. They don't cost a lot to produce, but they're much more sensitive than anything else that's out there by order of magnitude. And like they're and we've done a competitive analysis on them. They're the only ones who can make this. They have some IP. They also have a pretty big lead in manufacturing, right? That, I don't want to call them a monopoly, but they're really the only supplier of these really advanced, affordable sensors. But by comparison, there are 12 companies making CPUs today, right?
Right.
At least, right? So which one of those is the commodity, right? Sensors aren't a commodity anymore, not the really good ones.
Right.
And I think that's like, to me, that's kind of like mind blown.
Yeah. Well, and I think the amount of time, right, that's passed, right, to some degree, obviously COVID did a disservice because it focused the foundries and product companies on very specific things. But like you said, because that technology got better, it got more efficient, it got able to handle lower power. So things that might need more, to live in a field for 3 or 4 years on a small coin battery can do so now. But that wasn't the case, right? 5 or 6 years ago, when we were talking about these, whatever it was, 25 billion connected devices by 2025 or whatever. And so you could see how this market opportunity is really shaping up, which I think is interesting. And that's why I think you're starting to see more momentum here, if you will, across the board, right? Pressure sensors, air sensors, temperature sensors, everything is now starting to be like, hey, we're doing volume again. There's interesting in our products. You've got, NXP, you've got TI, you've got Infineon, all these people now starting to say, we're seeing momentum back in this category, but yet, you still just don't hear a lot about IoT being talked about.
Yeah. I actually think that the pandemic helped in other ways because I've talked to a few companies who were able to accelerate their sensor network deployments, their IoT deployments during the pandemic because everything else was locked down. So it was much easier for them to get access to all the places they need the sensors.
Right.
And so those are still older tech back, 2020, but it sort of reinvigorated everybody's interest in viability. It's still out there, and they were able to move on that and execute on their plans, and that sort of move things forward.
As always, parts of these discussions, it's interesting to talk about a architecture point. I know that not everything is ARM based, but there is a lot of ARM conversation around IoT. But even ARM itself, when they talk about the IoT market, they're like, it's lower, high volume but lower price. So what's your thoughts on maybe more of this starting to take shape around risc-v or risc-v even starting to enable some more of this? Perhaps in ways that might not have existed before a open source architecture existed.
Oh, 100%. ARM doesn't want to talk about IoT because I think they've lost big chunks of that market already. I think anything embedded, what we used to call embedded systems that go on other machines, IoT, simple sensors, low end sensors, cheap stuff. That's heavily going to be risc-v. There's no question about that. Certainly, all the companies in China that are building to this market are on risc-v. And anybody new coming into the market now is likely to go down that path as well. I think it gets a little tricky though, because for a lot of these things, you don't really need any architecture. You need a microcontroller.
Right.
But there's going to be a big category where you can just throw in some cheap digital logic because you have a risc-v core in there. Right. I think there's another architecture question though that we sort of need to sort of address. And I've been working on this a little bit in the context of automotive. You and I talked about automotive last week, I think, where in a car, and I think this holds for other industrial IoT systems as well, you're going to have a lot of sensors, right? You're going to have, in a car, you have speed and LiDAR and sonar and radar and all that stuff. In industrial systems or, pipelines, you're going to have temperature and pressure, lots of different sensors.
Right.
The question is then, we're going to need some kind of sensor hub or sensor fusion system. And there's a good debate right now about whether or not that will be something like a true processor, or will it just be a microcontroller? We can sort of quibble about the definitions of those. But there's a good argument to be made that because of a lot of things I talked about before about who's really controlling the value here, you don't necessarily need a full-blown, CPU for a system or CPU for a car. There's a good argument that we can make do with a lot less. And I don't know the answer to this. I think, it's obviously going to be a little of both, but there is a pretty big category of devices here where you don't need a processor, and you may never need that. But if there is a processor, chances are pretty good it's going to be RISC-V.
Yeah. So that brings up an interesting question. I mean, I've talked to and this just might be by nature of the types of companies that reach out to me and that I have conversations with, but the vast majority of RISC-V companies I've talked to are trying to solve really heavy compute problems, not some of these small things. And I know you made the point about China, but I'm not seeing, a US company, right, or a startup come in and say, hey, we've got this platform. So I'm curious, right? Do you think that's something that like Cypress does, or TI does, or NXP or Infineon, like the companies who are traditional? Do they say, hey, we're going to do this for the RISC-V because, one, it's something we can proprietarily do our own, so it's not an ARM architecture core or some small commodity off the shelf from a vendor. It's something we can do, or will it be more startups? What's your thoughts on that path?
It's interesting. The hottest chip right now in automotive is not Qualcomm, and Qualcomm's doing really well in automotive, but that's kind of a long-term roadmap. The hottest chip at the moment in automotive is an 8-bit TI microcontroller, right? And they've added a little bit of digital. They've added some digital logic to it, so it can run very basic AI functions. And there are a lot of auto companies who really are thirsting over that exact product because it's right for they have their reasons. Long term, I think the automotive sector, like we talked about, favors Qualcomm. That'll be a bigger processor. But for industrial systems, like having a lot of it's analog, so you want to go with an analog company and then throw on a little bit of digital.
Right.
The big question everybody has, though, is, so TI's is an 8-bit controller. What happens when we want to go to 16 or 32, right?
Right.
Analog companies in general don't have great digital skills.
Right.
And so I think for some of the traditional big analog players, TI, ADI, ON, they'll have a market. They'll have a big market to go after, which is adding a digital core next to an ADI to a controller. But once things get a little bit bigger, once you start adding more digital, it gets tricky for them. So I don't know. I mean, I actually worked at a quasi analog company for many years, and whenever we'd have product planning meetings, and we'd say, okay, now we need to add some digital logic to this, and the head of engineering would say, well, wait, who's going to do that, and who's going to do the actual digital work? And they'd always say, oh, get Digital Dave to do it.
Digital Dave.
There was one guy at the company who had background in digital technology, right? And I think that's going to change, but it'll be a very, very slow process. For the right. I think in China, what we're mostly seeing are just very, very bare bones stuff. So somebody will be small teams working analog products. they'll have a couple people doing digital. They'll throw the risc-v stuff on. The interesting part for me, though, is what are going to happen to the sort of the U.S. sensor companies. And I think there are, there's a few dozen that I can think of emerging, and they're all trying to figure out how to go through this. They're all trying to do it. And I think it'll actually be easier for them because they're new and they're nimble, and it's easier for them to add digital capabilities fairly quickly. Right? You can add, if you have 100 people and you add 20 digital engineers, that's 20% of the workforce.
Right.
Adding 20% to TI's workforce is thousands of people.
Yeah.
And it needs to be on that scale. And so it's just going to be harder for the big companies to do it. And I think that the newer companies, startups are more nimble by definition. And I think that's really where they're going to shine, is taking analog capacities and pairing it with some basic digital processes and building something more powerful. Right.
And at the end, like, even though you said, this is a highly series of markets that are a series of markets, I think the main point is it's huge. It's a huge market in terms of opportunity, which to some degree, if it's that fragmented, will allow for more competition, perhaps even competition amongst variations of architecture, different parts of the software stack. The other thing that I think is interesting is as companies perhaps start to embrace more of this generative AI stuff, it actually makes it a little bit easier for them to analyze or see value from all the data that they're collecting in real time from any number of parts of their ecosystem. But that's like just happening right now. So it's still kind of a long time, or a couple years off, I guess, in terms of overall timeline, because some of this would maybe be on-prem or hybrid cloud. But the point is that as we move to that market, it actually makes even more sense for them to collect all this data, right? This massive amount of data that they have, because it actually makes it easier for them to analyze.
Right. And I think, I don't know what to think about LLMs and GPT yet. I'm working on that. But I do think, in general, advances in AI, just that we've seen so far, will have two ways to play out here. One is, like you were mentioning, like I talked about before, is you'll have all this data from sensors. You can do more things with it. It'll be easier to peel that data apart. That's important. I also think it will get easier to design these products, right? That seems to be a big part of what's going on with generative AI right now, is supporting code design, right? And that, I think that there are already plenty of people working on improving chip design using AI-like tools. And I think that's actually, I think, going to come sooner. We've already seen a lot of EDA tools improve on this front, and I think we're going to see more of that fairly soon. So there's certainly an undercurrent of that in NVIDIA's GTC keynote.
Right. Yeah, it'll be interesting to see, I think, how parts of that. There's a lot of discussions around this whole LLMs and ChatGPT, and I think, though, what's become clear is whether or not that's some hybrid of your data and the large models that are out there. The bottom line is it's going to empower a lot of people in some way to make more sense of the information that they get, which I think has been part of the problem. I know from conversations we had with the ecosystem, even early on, who were starting to deploy wider IoT stuff, call it retail, or others, they were like, look, I've got all this data, but what am I going to do? I've got to hire data scientists. I've got to run all this. So that was really expensive and to some degree overwhelming, for a lot of companies, because they just didn't know what to do with the data. This might help with some of that, which I think is interesting. But it's, again, as we talk through this, it just keeps hitting me. Yes, we'll get there. In my brain, my timeline wasn't like, oh, this happens next year anyway. But there's all these important pieces of the puzzle that have to line up to get us to this point where now implementing sensors, managing those sensors, gathering data from the sensors and being useful makes a lot of sense, right? So it's still just this progression of things that need to happen amongst a timeline. And then once you're there, absolutely, everything you can connect it, because you've got the infrastructure to handle it.
I agree. I agree. I mean, there's
Yeah.
there's both sides of it. It's supply and demand.
Yep.
I just tried to get ChatGPT to draw me a circuit diagram, but it doesn't do pictures. It's giving me a pretty good description here.
Not yet, but at some point.
At some point.
Yeah. All right. IoT. So that was our thesis. We can wrap on that and leave more to talk about for the coming months. But thanks for listening, everybody. Send your comments as usual, and we will talk to you next week.
Bye, everybody. Thank you.